Yeah, vielen Dank. Thank you so much, Matthias. And it's a privilege to be here. Good morning, Staatssekretär Ludwig Thuysen, and of course, dear Barbara Grabkowski. I think this is a tremendously important initiative that you have been going on for a long time, but this is a very special moment in time to really focus on Umwelt innovations. I think your point about Niedersachsen being one of the Silicon Valley areas for innovation in sustainable agriculture is absolutely fundamental, because we are at the super year 2020. We know scientifically that we need to start transforming towards a decarbonized future for humanity in the world to stabilize climate. But we also know, which is very seldom discussed properly, that the final battleground, whether we will fail or succeed in delivering on the Paris Climate Agreement, on delivering on the UN Sustainable Development Goals, is whether we are able to succeed in the transformation of the food system towards healthy and sustainable, resilient food systems to deal with rising frequency of shocks and stress that we are more and more familiar with, also in Niedersachsen and in Europe, on droughts and heat waves and disease patterns, floods, but also to avoid tipping points, deviating away from a state that can support 7.7 billion, soon to be 9-10 billion co-citizens in the world. So this is a strategy issue. It's an agenda about avoiding turbulence around the world, which would in the end hit also Niedersachsen, hit Germany, hit Europe, hit the world. Now, what I'd like to do is to carry out what you could call a scientific overview of the framing of why Umweltinnovation in agriculture is absolutely fundamental, why the Nachhaltigkeit story today is no longer an environmental story, it's a story of security, prosperity, and equity, and why food is at the center of this agenda. Scientifically, as I'm sure you're so well aware, we have now concluded that we've entered a whole new geological epoch, the Anthropocene, anthros for us humans. We're the dominant force of change on planet Earth. We see this manifested in so many ways, and I'll walk through some of the scientific updates here. Let me just give you a little rundown of what happened behind the scenes of the COVID-19 crisis. I mean, it's almost like it's ages ago when Australia was hit by the most devastating forest fires that has ever been recorded in the country, hitting not only humans in a catastrophic way and agriculture and forestry, but also biodiversity, and leading to a pulse of 900 million tons of carbon dioxide emitted to the atmosphere because of this freak forest fire, which is 2 times the annual emissions of the nation Australia, one of the big coal-fire plant countries in the world. This is just to show the power of biosphere feedbacks when systems like farming systems and forest systems destabilize. We also know that the COVID-19 crisis is a manifestation of the Anthropocene. They're not disconnected. We have so much evidence that it is the increased penetration, particularly from agriculture in natural ecosystems and habitats, that leads to zoonotic spillovers from wildlife, often via domestic animals, to humans in the interaction between exploitation of natural ecosystems, deforestation due to agriculture, wet markets and wildlife trade in a globalized, hyper-connected economy, which leads to these kind of frequent increases. We've seen a trend line the last 20 years with a rising frequency of these kind of epidemics, like the SARS, all the way to pandemics as COVID-19. This is the new reality. We're living in a turbulent world where we're starting to see human pressures hitting the biophysical ceiling of what the planet can cope with to remain stable. This is, I would argue, one of the most important scientific questions we're facing today. Are we at risk of destabilizing the planet? Now, I'd like to just kick that off straight off to just share with you what I think is the most humbling and important understanding of why that question is so fundamental to us, why it's now so important to take on a Nachhaltigkeit and an Umwelt strategy that is on an innovation and transformation pathway. You may have seen this result. It comes from colleagues at the Potsdam Institute, Matteo Willett and colleagues. For the first time, running a physically based climate model for the past 3 million years. So that's what you see on the x-axis here, the whole Pleistocene geological epoch. On the y-axis is deviation of global mean temperature from the pre-industrial average, the zero line. And the green here is the modeling efforts. We've come so far today that we can reproduce the cycling between interglacials and glacials, interglacials and ice ages. And in black, you see the validation points against proxy data from trees all the way to the ice core data from 1 million years to the current time. What is so humbling in this graph, in my mind, is if you look carefully at it, you see that not one time over the past 3 million years has the global mean temperature ever exceeded 2 degrees. That is something that is fundamentally important to recognize, because the reason for this is that the Earth system, it's not that the Earth system has not been hit by external orbital forcing, earthquakes, asteroids, volcanic eruptions. Oh no, it is that the Earth system is an interconnected, complex, self-regulating system where the physics and the biology interact to dampen or reinforce the state of the planet. And we've kept ourselves oscillating with this tremendously narrow range, maximum temperature up to 2 degrees and a minimum temperature down to -4 or 5 degrees Celsius. Deep ice age, warm interglacial. Deep ice age, warm interglacial. Today we are at 1.2 degrees Celsius warming caused by fossil fuel burning and land use change. We're on a trajectory that would take us to 3.5 degrees Celsius by the end of this century. A point, if you wind back the geological climate clock, corresponds to the temperature on Earth, as far as we know today, some 5-10 million years ago. So you barely need any more climate physics to step on board and understand that we are in a situation of dire challenge and dire serious movement forward. In 2018, before this Pleistocene research was published, we did for the first time an effort of trying to take stock on the tipping elements research, meaning what are the biophysical systems that regulates the state of the planet? You've probably seen this tipping elements map that was produced the first time by Tim Lenton and John Schellenhuber and colleagues, in the end of the 1990s. This was an update in 2018 where we synthesized the knowledge of how are these tipping elements in terms of their sensitivity to cross tipping points. At what temperature levels could they potentially tip over? And in the yellow ones, you have those that show evidence of being at risk of tipping over between 1 and 3 degrees Celsius warming, meaning that we are already in the danger zone. On the Greenland ice sheet, Arctic summer ice, for example, that 2020 shows another record low in sea ice extent. You have alpine glaciers that are moving very fast in the wrong direction. Coral reef systems, as you may know, the report 2020 is the third coral bleaching in 5 years' time. That has never occurred before. A frequency of coral bleaching that has come to a point of almost annual events, which means that today 50% of the world's largest marine ecosystem, the Great Barrier Reef, has crossed a tipping point of irreversible change. But then you have systems that are more resilient, at least as far as we know, that may not tip over before we reach higher temperatures, up to 3, 4, 5 degrees Celsius warming, like the East Antarctic ice shelf, but that they are connected with other systems, which mean that you could trigger a domino effect. That if we burn fossil fuels up to 2 degrees Celsius warming, that could lead to feedbacks of the biological systems up to 2.3, 2.4 degrees Celsius warming, which could then start a domino and let the world start what we call sliding away, as showed in this hothouse Earth paper graph that we published in 2018, where you have the stable interglacial Holocene state, the state we've been in for the past 12,000 years, in the foreground, and how we are eroding this stable little cup of stability, eroding it by unsustainable agriculture, deforestation, overfishing, burning fossil fuels, air pollution, meaning that we are kind of shallowing down this resilient state and the system starts sliding. And we are today in this sliding point, the Anthropocene. The Anthropocene is not yet a new state, which is the big luck for us. It's not as if we have tipped over away from an interglacial state, but we are at this pressure point of sliding. And the big question is, the grand question is, where is a potential planetary threshold beyond which we cannot step back. We don't know where this is, but our conclusion in this research, which came before the Pleistocene modeling analysis, is that once you cross 2 degrees Celsius warming, we cannot exclude pressing the on button of sliding away in a way that makes it very difficult to turn back. And that our big challenge today is what we call a stabilized Earth, to be governors of all the global commons, to work together to govern the planet, and that agriculture is a fundamental part of this, and that is our big task today, to recognize we need to now govern the stability of the whole planetary system. Now, this means, just to conclude that kind of intro part, that the climate crisis is not disconnected from the health crisis. We know that heat waves, disease patterns, floods, droughts has tremendous impacts on human health, but it's also linked to the ecosystem crisis, which is all related to agriculture, to maintain the carbon sinks in land use systems. You know, of course, that land-based ecosystems continue to absorb in the order of 20 to 25% of the emissions caused by our fossil fuel burning. This is not occurring in agricultural land, which is a net emitter, but it's occurring in natural ecosystems adjacent to the agricultural land. This is one of our big necessities to keep these carbon sinks intact. And the health crisis I mentioned already, how it's interlinked, the COVID-19, to ecosystems and climate. Just one little story here, of course, is the drama around the food riots in Kenya, which are an effect of droughts in 2019-2020, the desert locust invasions we're seeing right now, undermining yield levels of staple food crops, in particular maize, leading to food riots, exactly in a situation where you need social distancing to deal with the COVID-19 crisis. You don't want these kind of local perfect storms between ecology, climate, and health. But that is what we're starting to see the first signs of. That is why a few months before COVID-19, together with the Club of Rome, we sat down and communicated for the first time that it may be necessary for us to now consider declaring a state of planetary emergency. And this is not a decision to be taken lightly, of course. I would even argue it can only be done once in human existence on planet Earth, because either you never end up in an emergency state, or you have an emergency and you sort things out, you deviate away from catastrophe, or it becomes too late. So it happens once, and we think we are at that point now. Why do you declare an emergency when you think of it? Well, there are two factors. Factor one is risk, and we conclude unequivocally that we're facing unacceptably high risks. I mean, not necessarily tomorrow, but for generations to come, when it comes to particularly undermining our food security ability as the planet warms. But the other factor, which is always a fundamental parameter, whether or not we declare a state of emergency, is time. And it's only an emergency if you're running out of time, if you have to do things very quickly. And our assessment is that we have been trying to communicate climate risks for the last 30, 40, 50 years. And now we've come to this juncture where we're running out of time. We have entered the decisive decade. We've entered the decade when we need to transform. We need to cut emissions by half until 2030. The European Union has even decided this. This is not an incremental change. This is a transformation. And it's hitting, or rather it's a challenge for all economic sectors in society. So there you have the reason why an emergency declaration communication, not to scare or doom, but to unleash innovation and transformation, to be an emergency for emergence of a new plan, a kind of an Earth shot equivalent to the moon shot. Now, where are we in terms of the backgrounds to this? Well, the first one is, of course, that we welcome humanity to the Anthropocene. Just to tick off that that's not based on hypotheses or theories, it's based, as you know, on the hockey stick patterns that we see across the entire world in terms of rising pressures on Earth systems on the planet. Now, as you look at these graphs on hockey sticks that were first produced in 2007, 2008, they all bend at roughly the same time. So it's from the 1950s onwards that we go from incremental pressures on the planet to exponential pressures on the planet. So when you think of the hockey stick of carbon dioxide, you know we have the same hockey stick patterns for biodiversity loss, for overloading of nitrogen and phosphorus, for deforestation, for air pollution, for sulfates, for salinization, for microplastics. It's essentially the same pattern. In fact, we quite recently even published for health that we have a kind of a similar pattern of the great acceleration for health. And just to highlight a few issues here, to the furthest right, you see the graphs on biodiversity loss, on water use, agriculture being the predominant user of fresh water. 70% of water withdrawn in rivers and lakes and groundwater are used to produce food. But on the furthest left, you have antibiotic resistance, as you know so well, is also a very deep concern across the world. We also have in the upper right-hand corner this enormous challenge that we have, stunting being a tremendous problem in the world, but we actually today have obesity rising up as a bigger challenge, even in the developing world, compared to malnutrition, undernutrition, and stunting. And then we have the rise of different food-related vector diseases and viral diseases connected to zoonosis, for example, on the COVID-19. So this is a pattern of change we're seeing in the Anthropocene. The second insight is that, we are deep in the Anthropocene, we are shaking up the whole system, and at the same time, we are landing in the conclusion that the last 12,000 years, the Holocene period, we left the Ice Age 12,000 years ago, the last Ice Age, the interglacial warm period we've had over the past 12,000 years is so extraordinarily stable relative to everything else in the planet's history that I would call it the Garden of Eden. It is the only state we know for certain that can support humanity. You've probably seen this graph, which has many, many equivalents, which comes from ice core data from both Antarctica, Greenland, showing the last 20,000 years. And again, global mean temperature on the y-axis. The zero line here is the pre-industrial zero line. You see how we at minus 4 degrees Celsius are in deep ice age. We leave the last ice age starting 20,000 years ago, 12,000 years ago, we kind of step out of the ice age. And then we enter this blue, extraordinarily stable, what I call a plus minus 1 degree Celsius world. Yes, plus minus 1 degree Celsius world. We've had tremendous variability over the last 12,000 years. We've had wet and dry conditions in the Sahara. We've had the medieval warm period. We've had the little ice age, but these were all regional occurrences within this narrow range of plus minus 1. We are today outside of the Holocene. We've actually bumped right outside the maximum temperature on Earth since we left the last ice age, 1.2, and we're hitting towards moving away even from the Pleistocene, going into the Pliocene or the Eocene type of temperature. The Holocene is therefore our desired state. It's our reference point. It's the planet we want. Now, the good news is that despite all this pressure, it's still just a pressure. The Earth system is so resilient. Everything that agriculture is about, soil, water, forest, landscapes, these are parts of the fabric of strength on the planet that are still operating. So the challenge for us is to use this window that is still open to transform and sort of say, become stewards of the entire system. And agriculture is the number one steward on land. Fisheries is perhaps the number one steward in the oceans, to be able to remain in this, what I call now a Holocene-like state. Now, we see how land is shaking up under these pressures, how challenging this is, but we're also seeing more and more science being published on the opportunities of nature climate solutions, of solutions to work with management of agriculture, with restoration, with regeneration of landscapes, to use them as carbon sinks and promote biodiversity increase. But of course, we also have to remember the trend lines on biodiversity, which in my mind is the most dramatic negative trend, potentially even more dramatic than our exponential rise of greenhouse gas emissions. German ecologists that you've said have been absolutely leading in understanding and mapping. I mean, now last in the global assessment of the IPBES, the Intergovernmental Platform on Biodiversity and Ecosystem Services. I think that the work that has been done here in Germany on pollinators and their role and the trend lines are absolutely fundamental to recognize how dependent we are for food systems on having high biodiversity and rich landscapes. We also know, as you certainly are at the frontier of, this challenge of transformation that we've done over the past, thousands of years, where we today have, a remarkable 96% of the weight of mammals being domestic animals and humans. Only 4% today are wild mammals. And at the same time, we are at this 6th mass extinction of species in terms of losing mammals, plants, fish, marine mammals, that we are, taking big risks here of losing the resilience in the system. That's that Secretary Torres pointed out in the beginning that we need to have as a component in building strong societies into the future. We also know the links, as I mentioned earlier, between natural ecosystems and zoonotic disease outbreaks. I think it's just worth mentioning that 75% of the zoonotic virus outbreaks, as we know them up until today, originates from primates, apes, bats, and rodents. And that this is more of an hypothesis, but that when we simplify diverse natural ecosystems into more monocultural-based, urbanized ecosystems, we get generalist species to thrive, while we reduce, even to extinction, those that are more specific to their own habitats, which means we get a rise of particularly rodents, which are one of the engines behind epidemic zoonotic viral outbreaks. So we need to understand this complexity around why it's important to keep natural habitats intact, which can then work in harmony with agriculture. I want to also give you a little update before coming into the food side, that we very recently took the first map on the tipping elements I showed you in the beginning, for the first time showing how they're interconnected. And we did an assessment in 2019, again, just before the corona outbreak, showing that 9 of the 15 known big tipping element systems, tipping elements, as you see here, like the Greenland ice sheet, the West Antarctic ice shelf, the Atlantic circulation of heat, the AMOC system, that 9 of these known 15 are showing signs of rising variability, that they are, to put it simple, on the move, that they are coming too close for comfort to points where we cannot exclude that they would abruptly shift in an irreversible way. But most importantly are the arrows you see in this graph, that we see more and more scientific evidence that the rapid loss of the Arctic sea ice and the rapid loss of ice on Greenland is affecting the ocean circulation in the North Atlantic, which in turn is affecting and holding more warm surface water in the West Antarctica, in the Southern Ocean, which then accelerates melting of ice sheets on rock in West Antarctica, which then could accelerate sea level rise across the world. And these interconnections, these so-called teleconnections, are increasingly understood. It's at the science frontier, but I think that's also something to be aware of when it comes to our planning for innovations also in land management systems. We cannot exclude, as you know, that the heat waves and extreme throws back and forth of weather systems in Europe can also have teleconnections between the Arctic and the jet stream and the locking through the different Rossby waves of low pressure, high pressure systems. We don't know this for certain, but there's more and more science coming out that for summer periods at least, that seems to hold, meaning that the kind of heat wave we're experiencing right now in Germany might be actually related to the melting of the Arctic. So this is these are the kind of teleconnections we need to understand. Is all this just single research groups around the world coming out with interesting science papers? I would argue no. This is, in my mind, the most important confidence building graph we have today. This is a very, very small report published last year by the World Meteorological Organization, the IPCC, and Future Earth is the world's largest community of global environmental change researchers, called United in Science. What you see to the right here is 19 years of IPCC assessments. And it's the famous red embers diagram. The darker the red, the higher is the scientific assessed risk. On the y-axis here is, again, deviation from global mean temperature. So you have 0 line, but then it gets warmer and warmer and warmer up to 6 degrees Celsius. You have 3 clusters. To the left, you have the cluster on risks for ecosystems. On the middle, you have the cluster for extreme events. And to the furthest right, you have the cluster on triggering large-scale discontinuities, basically irreversible tipping points, basically related to the tipping elements I just showed. Each column here is one IPCC assessment. Furthest left, state of knowledge, third assessment, 2001. Then you have fourth assessment, 2009, fifth assessment, 2014, and 1.5 degrees Celsius report, 2018. 19 years of advancement. Step back and you see immediately that the more the science advances, the more we learn, the higher is the risk. And that just 19 years ago, our assessment was that we did not stand risks of large-scale discontinuities before we ended up something like 5-6 degrees of warming. It was like a non-risk. There was nobody suggesting that we were following a trajectory that would take us to 5-6 degrees Celsius of warming. Today, the assessment is that already between 2 and 3 degrees Celsius warming, we cannot exclude not only hitting irreversible ecosystems, triggering massive extreme events, and crossing permanent tipping points. This is the IPCC assessment. This is like the floor we stand on in the scientific assessment. So that's where we are. You've seen the land report that came out last year, that has all the relevance for planning for Umwelt strategies for agriculture on water scarcity, soil erosion, etc. We won't have to go through this. The only point here is that even this shows that between 1.5 and 2 degrees Celsius, you go from the yellow to the red. You go scientifically in the assessment from danger to high risk. And that this is something that gives even more support that we do face real challenges. This is a map that we generated at PIC for the fifth assessment IPCC, showing the risks at 2 degrees Celsius warming of water scarcity. And you see in the orange zones here, the regions of the world that we then, a few years back, assessed would risk 25% or more reductions in rainfall. And you see the areas that are today increasingly affected. I mean, Southern Africa, mid-US, Southern Europe. I mean, these are getting more and more empirical evidence that these data are correct. So it's not a coincidence that we have concluded, increasingly in the scientific community, that we need to have a new kind of guidance framework for agriculture, for cities, for businesses, for all sectors. And one of them could be the planetary boundary framework, because the planetary boundary framework tries to ask the question, what are the biophysical systems we need to take care of, be stewards of, govern, to be able to keep the planet in a Holocene-like state? And what are the quantitative science-based targets that can give us a safe operating space in green to guide us, not to warn us only, but to guide us, so that we don't enter into the yellow zone, which is the danger zone or uncertainty zone in science, or the red zone where you actually risk triggering major changes. This is the 2015 update. We're actually working on the 2020 update right as we speak. What you see is that we have 4 of the 9 known boundaries, either in the yellow or in the red. The most serious ones are biodiversity loss, nutrient loading by geochemical flows here, and land system change, and of course the climate boundary. You know that food is central to all of these, and that is why a transformation to sustainable food systems can be the most effective way of coming back into a state that can support humanity. That's why we launched the Eat Lancet report, for the first time gathering science to address sustainable, healthy diets. Of course, building on the stats that you all know of how challenging the food system is. I just want to emphasize again that we have 150 million stunted children, but we also have 2 billion people that are overweight. This is a fact that we have to deal with in the development of the world. Quite recently also, there was this Food and Land Use Coalition report that did a first back of the envelope assessment of the value of the global food system to $10 trillion, showing that if you just incorporate externalities like pollution, degradation, chemical overuse, loading of nitrogen, phosphorus, the cost would be slightly above those 11 trillion. So that's just one reminder of the challenges we are facing in the ag community, so to say. And then what you see here is also the fact that inequity is built also into many of these systems. This is an example of how large share of a cup of coffee bought in Berlin, a 250 euro cup, does in the end the small-scale farmer receive. And it's like 1% of the 10% that goes to the grower. So it's also a factor of the whole value chain in the agricultural system. I'll jump this one for the sake of it. The Eat Lancet Commission did some really important progress on trying to define quantitatively the safe space for health and sustainability on food. I'd just like to share with you some of the kind of numbers here. We took a planetary boundary framing, both for health and for sustainability. We did the first attempt of looking at the food system's transgression of planetary boundaries. So this is the food analysis of the responsibility of agricultural systems for transgressing safe boundaries here in green. And as I mentioned before, food is a major cause behind greenhouse gas emissions, loss of biodiversity, land use expansion, consumption of fresh water, and overloading of nutrients and phosphorus. I mean, this is no news to you at all, but it's just to say that the planetary boundary framework can be used as a science-based target framework to define the goal for the Umweltinnovation strategy, for example, in Niedersachsen. I mean, it can be used at different scales, at different sectors. We set up scientific targets for healthy diets on all food groups and tried to summarize as much as we could the health science as best as we could. Walter Willett from Harvard University led that work. We also did an assessment then on the quantifications for the boundaries that are most closely associated with food, and you know them and you have them here. On health, what this showed, and I won't go through this graph in detail. If you wanted, I'll share this. You have this PDF file. But just to say that from a health perspective, and that's where we started, what our synthesis showed in terms of summarizing how to define a universal healthy diet is to transition towards what I would call a flexitarian diet. So it's not a vegetarian diet, but it's actually quite a significant transition from our current diets, particularly in the developed part of the world. It's a diet that has more nuts and fruit and vegetables increasing. It is a diet that has much lower animal protein on average for a German or a Swede, going from 700 grams per person per week to 150 grams per person per week. So that's quite a dramatic change, but it's not shifting away from animal protein entirely. It actually corresponds to 5 servings of animal protein per week, but only 1 serving of red meat, 2 servings of white meat, chicken, and 2 servings of fish. And that this is what makes it a flexitarian diet. It's quite similar to the traditional, what is called the Mediterranean diet, which is quite dominated by unsaturated oils, more vegetables, more fruit, and more nuts. It's just to say that that was the health assessment that we landed in. This corresponds visually roughly to what you see here. It's kind of a 50% of the food plate is from the plant world, and the other side is from dairy products and animal protein and different tubers. So it's not a vegetarian diet, but it has this kind of flexitarian setup. It would have quite some dramatic implications. Here you see the percentage changes it would mean globally. So for whole grains, it would be roughly the amount of grains that we're producing today in the world. But what you see in green here is big increase in vegetables, 75% increase in growing vegetables. Fruit, quite a significant 65% reduction in red meat production, but then a massive increase in nuts, beans, lentils, peas, and fish. So fish is a challenge, of course, because that would suggest that aquaculture would play an important role, because we see very little window for wild fisheries to expand, and a slight decrease in egg production in the world. This is, of course, something that then has to be dismantled down to regions, and it will be quite exciting to look at the Eat Lancet universal diet for a Niedersachsen context, potentially as a research project. This is how it would look like in a kind of a universal translation of what this means for a daily intake. So quite a diverse set, but you can see it directly, kind of a shift in composition. It is certainly not a monoculturalization of one diet for the world. It's setting a framework of what the science say gives us the best opportunities for good, healthy lives. But it can then be translated to very many type of cultures and dietary traditions. Well, I think you might recognize here the Himmelen und Erde in the lower left-hand corner there. And of course, my beloved, I just cannot stop eating spargels when I'm here at this time of the year in Germany. So it's not about streamlining in one direction, but it's about recognizing that healthy diets are important today. We also came out just when the Lancet was printed with 3 independent studies showing that unhealthy diets is today causing premature death of 10 to 11 million people per year. And it was quite interesting that this came from different studies. So you have the Global Burden of Disease study, you have some Oxford study, and you have one from the Lancet work. And remember that, I mean, COVID-19 has today caused a mortality rate of 750,000 people. Air pollution kills 5 million people in the world, but food is in these estimates killing roughly 10 million per year. So we see that this is serious. This is big stuff. Healthy diets would mean a big shift. Here's another way of visualizing that. You want to stay in this circle, and you see here that dairy and starchy foods are the ones that are very far out when you take it to a global average. So this is one of the challenging messages. When it comes to sustainability, then to close, I mean, we have been able to quantify the planetary boundaries for food at a global level for all these boundaries that are most closely associated with food. We took those numbers into an assessment of the transformations we now need to accomplish for climate. You see it visualized here coming from the IPCC, actually, how we need to, on the x-axis, time from today, 2020, bend the global curve of emissions, the gray part here, and reduce emissions to roughly 0 emissions by 2050. Our conclusion is actually that the food system will never be able to be completely a zero carbon equivalent system, because there is nitrous oxide, there is methane related to even sustainable livestock systems. Extensive grazing systems are fundamental to keep landscapes open and functioning. So our conclusion is that we have to serve or preserve a roughly 5 gigaton carbon dioxide equivalent for food production. If we're serious about feeding healthy food for 10 billion people, we have to go more rapidly on decarbonizing other sectors to give some room for food, because it's naive to think that we could simply just get rid of all emissions from the food system, while at the same time recognizing that the food system now has to occur on current cropland. We cannot continue expanding into natural ecosystems, and we can also adopt management systems that start sequestering carbon and building soil organic matter on farmland as a way of having win-win for productivity and resilience. This is quite an exciting agenda indeed. We did scenarios on this. I'll just mention very briefly that, you know, what you see here is on the x-axis is all the planetary boundaries. We adopt different variants of the diet. The upper line here, that the red and yellow one, is business as usual, meaning that what happens if we continue eating as today, continue wasting as today, then we transgress all the planetary boundaries in red. So that's not a path we want. You have to go all the way to the bottom line here, which is called the PROD plus, which is sustainable management systems and innovation. Cutting waste by half and adopting healthy diets can take us back within the planetary boundaries. This is just a message to you to say that we're talking about a transformation that must include innovation, not only in production, but also in demand and reducing waste. And that's basically the key message. We've done then a follow-up study at the Potsdam Institute of showing, can we feed 10 billion people within planetary boundaries? We think we can through innovation. On the left hand, you see with current practices, you could actually only feed 3.4 billion within planetary boundaries. Basically, if we produce as we do today, it would have to be scaled back to only feeding 3.4 billion if we are kind of thinking only about the planet. But if we go for water, nutrient land management, irrigation, fertilizer management, crop rotations, different forms of circular technologies, technology advancements in genetics, etc., we believe there is enough evidence out there that we can feed a world population within planetary boundaries. We come with a number of strategies on commitments and raising food to the international level, of trying to reorient agricultural policies from just productivity to quality and health. I think you at Niedersachsen are at the frontier of that thinking already. I think that is something that needs to be exported around the world. We also have the key that sustainable intensification, we think, is the path, not extensive agriculture alone. We just have to stop expanding and using modern technology, satellite-based precision farming, etc., to intensify sustainably. Here again, I think Niedersachsen is a reference point for the world. We need to have coordination between countries and between land and oceans. And I think this is, I've barely touched this, that the marine source of nutrients are also fundamentally important. And finally, what I haven't talked about either is the fact that 30% of the food we buy is wasted. And this is something that we also need to, of course, try to reduce and also build into our sustainable system. And my final graph is this one, which is a framing of this, and perhaps an inspiration for your discussions, is if now Earth system science says that we have to stay within a safe operating space of a stable planet, perhaps put the food systems and put the sustainable development goals inside this space for an equitable, healthy, prosperous future. And that is the new definitions for sustainability: prosperity and equity within planetary boundaries, a kind of a new way of connecting Niedersachsen to the planet at every innovation decision that is taken. That's why I'm so excited about this dialogue that you're having here today. Thank you so much for your patience.